In this video, we present LATTE, a tool for visually creating and deploying smart contracts. We will demonstrate how to use LATTE to create a smart contract for voting based on a reference contract available in the Solidity documentation. Blockchain and smart contract development is challenging due to the niche expertise required and the field's relative infancy. Our tool, LATTE, visually represents and simplifies the concepts in Solidity smart contracts. We aim to encourage involvement from new users and developers by letting them create smart contracts without prior experience with programming or Solidity. A smart contract can be written to ensure the transparency and fairness of an election. This is the Solidity code for a voting smart contract. In this smart contract, a chairperson will deploy the smart contract, and he is in charge of overseeing the voting process. The chairperson is assigned in the constructor, which is called when he deploys the smart contract onto a blockchain node. The chairperson can add possible proposals to the contract and give other people the right to vote. The require statements here ensures that only the chairperson is capable of calling the add proposal and give right to vote function. The vote function can be called by anyone with the right to vote and has not voted yet. His vote will be added to the proposal's mapping object which stores the vote counts, and the winning proposal function can be called by anyone to find out which proposal won. The delegate function allows a voter to give his vote to someone else to vote in place of him. In LATTE, the global state tab is used to create events and structs. The constructor is associated with the initial state tab and the rest of the functions will each be associated with a function tab. LATTE is able to infer the types of the global variables based on the user-defined logic. Firstly, we will connect to localhost 8545 which our test blockchain node is running on. The global state tab represents details of the smart contract that are not tied to any functions, namely, events and entities declarations. Events can be thought of as announcements that something has occurred to the rest of the blockchain. Entities are ways for users to group data together in a data structure. Events and entities have to be declared here so that they can be used later. At the bottom of the tabs, from left to right, the buttons allow the user to go back to the connection page, save and load their progress, generate the Solidity smart contract and save it, and to deploy their contract onto the connected blockchain node. We then create a voter entity with these attributes that will be used later. All tabs other than the global state tab correspond to a Solidity function that can be called by external users. All of our function tabs will have the same visual structure, containing a function input box, a checking phase box and an action phase box. The function input box defines the parameters that must be given to the function when it is being called. The checking phase box shows the checks that will be done before the function is run, and they correspond to require statements in Solidity code. The action phase box contains the drag and drop diagram that will be used to define the logic in the function. On the left, we have the node types that can be dragged onto the diagram. Here, we assign the message sender as the chairperson. We create a chairperson object to be stored in our mapping. We leave the delegate field blank to give it a null address value, because the chairperson does not have a delegate yet. We then create a new tab for add proposal. The function takes in the proposal parameter and checks that the function caller is the chairperson, then it adds the proposal to the vote count mapping. In give right to vote, the function takes in a target voter parameter. It checks that the function caller is the chairperson, the target voter has not voted yet and does not have the right to vote yet. We then set the vote weight of the target voter to 1. In the vote function, the function takes a proposal name parameter and checks that the voter has a right to vote and has not voted yet. In the diagram, we declare that the caller has voted and assign the proposal name to his vote. We add the vote to the vote count mapping and check if the proposal has the most votes using a conditional node. The current proposal will be the winning proposal if it has more votes than the previous winning proposal. In winning proposal, we simply return the winning proposal's name. The delegate function takes a parameter to and checks if the function caller has voted and that the function caller is not self-delegating. In the diagram, we loop through the to values of each delegated voter until we reach the voter that has no valid delegation. A conditional node that is connected to itself is interpreted as a while loop, so the voter's delegate will be assigned to the delegated to variable until the delegate is a null address. Here, we declare that the sender has voted and who the delegate is. We check if that voter has voted. If he has voted, we add the message sender's votes to the proposal that the delegated voter voted for. If not, we add the message sender's vote weight to the delegate voter. We can then click on the Generate Code button, choose a filename and save it. We can see the smart contract that was generated by LATTE here. We can also deploy it to the blockchain that we connected to earlier by clicking the Deploy button. LATTE is intentionally limited to prevent cluttering of the user interface and user confusion, as the target user is a novice user or developer. Any complex functionality will have to be added manually through code. LATTE's main focus is to maximize user-friendliness and enable smart contract development without programming or Solidity experience. We have demonstrated some of the major features of LATTE. User interfaces are crucial to the growth and adoption of blockchain, and LATTE will help to simplify learning and development on the blockchain and make it less intimidating to new developers.